The Optimize.ai is an AI-driven process analysis and process improvement platform, which uses the operations logs of the workflow to identify the process KPIs, their deviation, frequent user journey, user's happy path, and a gamut for process-based insights. The Optimize.ai provides process analytics capabilities like process data ingestion, process transition, process animation, process flow, and recommendations. The Optimize.ai provides the features for ingesting the workflow log data and create a process data. The process data critically includes task identifier, task name, user performing the task, actions taken, to name a few. These fields give richer information of the process performance and objectives fulfillment. The solution captures the flow-related metrics like average path length, number of unique paths, resources involved in the activities, and throughput time of the process. Further, it also identifies the sub-process that form a significant part of the overall parent process. In this case, we can analyze the flow-related metrics with respect to sub-process global check processing. In addition to flow-related metrics, it shows the control flow graph that shows the order of execution of tasks. Activity frequency shows the number of times that specific activity is instantiated in a sub-process. Optimize.ai identifies the tasks or activities that create a bottleneck in terms of execution delay, deadlock for other task instantiation, and similar scenarios. The transition activities are identified that contribute to the bottleneck of the process, thus affecting the KPI of the process. Optimize.ai also captures the resource utility measures of the process. These resource levels can be used for resource estimation and resource allocation for higher process throughput. Process automation presents the analyst with real-time simulation of the task execution in the workflow. It shows a very critical insight of the execution stages of any task entity, like user type, task type in the process, and in their effective time in process execution. The process transition feature shows the tasks that cause the impediments to the overall process throughput and shows the need for process transition. Optimize.ai shows various flows that have significant deviation in performance and give the details of the bottleneck tasks. The process deviation along with information of bottleneck activities are used to simulate in the process animation with selected level of process deviations. The process animation shows the required process restructuring and recommend the analyst to update the process for future requirement. We present to you the workflow to code. This solution converts the dumb process maps into BPMN 2.0 compliant code, which can be imported into a compatible BPMN modeler like Camunda. This is a no-code accelerator using the AI-powered cognitive intelligence which helps reduce the time and effort for moving from process documentation to workflow. An organization will have tons of documentation for the processes it wants to migrate to a workflow or from one workflow platform to another. This solution automates the low value-added task of translating the process flow to a skeleton workflow model. The analyst can then devote his effort on the value-added task of configuring the model and its deployment. Let's see how this can be conceptualized to deliver. First, the relevant process chart, which needs to be converted into the workflow model, is selected. This can be a diagram in any of the popular charting tools like Visio, or a document like PowerPoint slide, Word, or even a scanned, hand-drawn image. This is a preview of the selected flow chart. Now, we process this flow chart to decompose it into its parts. The object detection algorithms of workflow to code identify the objects in the flowchart like the task boxes, decision boxes, start and end boxes, and cross-functional lane. The arrows connecting the various objects and their directions are also identified. Thereafter, a custom-written algorithm creates a connectivity matrix identifying the objects and their connections with each other. The connectivity matrix is a representation of a directed graph, where the nodes are the objects identified, while the edges are the connections between them. The connectivity matrix can also be visualized as a directed graph on the left, while another custom algorithm converts it into a BPMN 2.0 compliant XML code. Now, we use a compatible workflow modeler like the Camunda modeler here. The XML code is directly imported into the modeler, which renders a skeleton BPMN workflow model. Now an analyst can take over and start configuring the attributes of the model and additional features. AutoCode is an automated software code development platform. It converts wireframes and visual designs in image format to corresponding HTML, CSS, and HTML-jet code. This solution has the ability to automatically learn web elements in hand-drawn wireframes and map them to corresponding code in HTML. It's a deep learning-based rapid prototyping platform designed to help design thinking teams, software developers, testers, and support teams. It can generate code from multiple input formats like wireframes and visual designs. It also comprises AI/ML solutions to check the vulnerability in code and suggestions to fix the code. This demo presents the capability generating the codes directly from wireframe models. Click on the Wireframe to Code button to upload the wireframes. In the wireframe upload page, you can use existing templates such as subscribe form, login widget, and register form. This rich source of existing templates saves time of the developer to search for new templates for standard set of requirements. You can also upload a handwritten picture taken during, say, some design thinking workshop and upload them. Once you click Upload of Handwritten Picture and select a picture, then you can choose either to directly generate the code or decompose to wireframe. Decompose the elements and then generate code. Identify the text boxes, text area, and other constructs. Deep Learning Models learns the respective codes for these identified constructs. The deep learning models then predict the code for respective object and create the code in HTML or CSS. It also shows the generated page preview in the output. Reuse the code directly on the code section to create the object and output. Export the code for further processing the code in other tools. Otherwise, click on Deploy button to directly deploy on Cloud Stack or some sourcing stack. Objects supported by AutoCode.ai include button, image box, text box, text area, combo box, search box, paragraph, help, logo, radio button, checkbox, table grid,